And we're going to be going over 12.3, trig functions of general angles. We're not going to finish going over this section today. We're going to do the first 2 pages and then we'll finish tomorrow, and I'll give you your worksheet tomorrow. So today we're looking at trig functions of general angles, and we're going to still be using the coordinate plane, the circle, but we're not going to use a unit circle today. Instead of the radius always being equal to 1, we're going to have different radius lengths, and we'll have to solve for those. So looking at the front of your notes, the trig functions of general angles, it says let theta be an angle in standard position and let pxy be a point on the terminal side. Using the Pythagorean theorem, you're going to find the radius, and the 6 trig functions of theta are defined below. So they're all blank right now on your paper. So as we go over this, you need to fill out the sheet so that you can have that to refer back to. And I'm going to redraw it a little bit bigger so you guys can see it better. So we're just going to start out with the XY axis. I'm going to add a circle. It's not, let's pretend like it's centered, okay? And the center of the circle is on the origin, and then you have this point that's on the circle, that's XY. So there's your radius. And I'm talking about this angle right here, this angle that's made with the x-axis. So I'm going to make a triangle inside this circle by making the leg, the adjacent leg, x units long because I'm using this point, and then I'm going to draw the other leg y units long to go down and meet to make that 90-degree angle. Alright, so this is going to be your r here, your radius. And we can find the radius by taking square root of a squared plus b squared. Now on your paper, we're just going to write the ratios down, and then the next one we'll do an example. So your sine, we're looking at this angle. Sine is opposite over hypotenuse, so that's going to be y over r. Cosine is the adjacent leg over the hypotenuse, so that's x over r. And tangent is opposite over adjacent, y over x. Now for cosecant, secant, and cotangent, you guys remember how to get those? Yeah. So the cosecant corresponds to sine. Your cosecant is going to be r over y. Secant corresponds to the cosine, so that's r over x. And your cotangent corresponds to tangent, so that's x over y. Any questions? Let's look at example 1. The terminal side of theta in standard position contains the point at negative 6, 2. Find the exact values of the trig functions of theta. So we're going to start out with my xy axis, and my point is right here. So I'm always using the x-axis to draw my triangle. Okay, I'm not going to use the, the y-axis to draw any triangles. And my angle theta is right here, using the x-axis. So I'm going to just go ahead and write down that x is negative 6, y is 2, and then I want to find the r. So I'm going to take the square root of 36 plus 4. the square root of 40. What would that be simplified? Two radical 10. Okay. So using the ratios that we wrote down at the beginning, I'm going to find my sine, cosine, tan, and then all the other ones. I'm going to do it right down here. It's a little more room. So the sine of theta is going to be y over r. Oh, I'm going to go ahead and put r, 2 radical 10. So that's 2 over 2 radical 10. And you want to simplify and rationalize. So the 2's are going to reduce out completely. And to rationalize, I need to multiply top and bottom by the square root of 10. So your sine works out to be square root of 10 over 10. Cosine is x over r. X is negative 6. R is 2 radical 10. And we're going to simplify and rationalize again. We multiply top and bottom by square root of 10. So we'll get negative 3 radical 10 over 10.
Miss Pepper, can you scoot the paper down?
Like that?
Yeah.
Okay. And then your tangent is y over x. So that's going to be 2 over negative 6, which simplifies to negative 1/3. Okay, so you guys go ahead and find the cosecant, secant, and cotangent. And I'll do it up here. You find the next 3. I'm getting radical 10, negative radical 10 over 3, and negative 3. Any questions? Is everybody good? Okay, so let's look at the bottom of your paper, at the quadrantal angles. So why do you think that they're calling these quadrantal angles?
Quadrants.
Yeah, they cover the 4 quadrants. You have the 360-degree angle, which goes all the way around. It's a complete circle. Then you have this first quadrantal angle that's 90 degrees, covers the first quadrant, second quadrant, third quadrant. So they're using the axis as a terminal side. So when we are trying to find tangent, cosine, and sine for these kind of an angle, you're not going to have a little triangle inside the circle like the other ones will give you, because it terminates on an axis. So you're just going to be looking at the x, y, and finding r with the equation that we used earlier. So we're really going to be focusing on using these ratios here. I'm not going to be using a triangle to find the ratios. So let's look on the other side. Example 2. We're going to do an example. The terminal side of theta in standard position contains the point at negative 2, 0. So it's right there. So what kind of an angle are they talking about on this one? It's in standard position. How big is that? 180. Yep. Makes a straight line. It's 180. Find the values of the 6 trig functions of theta. So I need to find the radius. I'm going to use 2 squared plus 0 squared. So the radius is going to be 2. X is negative 2. And y is 0. So your sine value is y over r. or 0 over 2, which simplifies to be 0. Okay, your cosine is x over r, which is negative 2 over 2, or, yeah, I always want to simplify. Okay, and then you have your tangent, y over x, 0 over negative 2, which is 0 again. Now the cosecant, you're actually going to have, whoops, didn't mean to do that. You're actually going to have 0 in the denominator, which means it's undefined, yeah. You'd want to put undefined for that. Then your secant is 2 over negative 2, which works out to be negative 1 again. And your cotan, I forgot to put the theta there, is undefined, right. Any questions? All right, let's move on to the reference angles. So here we are in the middle part of your notes. The reference angles are always from your first quadrant. And the reason that they use reference angles is because when you go have terminating sides like in your second, third, or fourth quadrant, you're dealing with bigger angles, and the sine, cosine, tangent ratios start to repeat. And so it's easier if you have a reference angle to think about those numbers, because it's after you reduce things down, it's going to work out to be the same anyway. So they're trying to save you some work by using reference angles. So in the first quadrant, the reference angle is just whatever your angle is. So in that little box below, you're just going to put the reference angle is whatever the angle is. Okay, if you have a terminating side in the second quadrant, your reference angle would be 180 minus the angle. So that is what you would do if you have a degree measurement. Pi minus your angle is what you would do if it was a radian measurement. And notice all of these angles, all of these reference angles, are the angles that are made with the x-axis. Okay, so if you have a terminating side in the third quadrant, the reference angle would be the angle minus 180, or in radians, the angle minus pi. And if your terminating side is in the fourth quadrant, your reference angle would be 360 minus the angle, or in radians, 2 pi minus the angle. Any questions? The bottom part of this is the last example we're going to do, and then we're going to save the rest of it for tomorrow. Example 3. You're going to sketch the angle and then find the reference angle. Now all of those reference angles are for positive angles, and part A gives you a negative angle. So we have to do actually 2 steps on this one. The first thing we want to do is find a positive angle that's coterminal with this angle. So what did we do yesterday to find coterminal positive angles? Okay, so in this case, if I want a positive one, I would add 360. And that gives me 250 degrees. So let's sketch that 250 degrees, figure out what quadrant it's in. If I start at 0, and then that's 90, that's 180, that's 270. So my 250 is going to terminate somewhere in the third quadrant, right? Mm-hmm. So there's my sketch. And since I'm in quadrant 3, I'm going to take the angle minus 180. The angle's 250 minus 180. And I'm getting 70 degrees. And that would be your reference angle. Now in part B, they give you the angle measurement in radians. And if you have that unit circle from yesterday that we made, that would come in handy about now, because you could look and see what quadrant the 2 pi over 3 is. Quadrant 2? Yep, you're right, it is in quadrant 2. So your 2 pi over 3 angle looks something like that. And from the chart that we just looked at, in the second quadrant, you're going to take pi minus the angle. I need a common denominator. Yeah, it's going to be 3, so I have to multiply pi over 1 times 3 over 3. So what is my reference angle going to be? What's 3 pi minus 2 pi?
1 pi.
1 pi, right. 1 pi over 3 will be your reference angle.